So, yeah, good morning, everyone. So, as part of today's session, we'll be continuing with the Python programs itself. So, until now, what we've learned is a lot of programs which were relating to list as well as strings. And then we covered a lot of functions also, which can be worked on a string to do all kind of frequently tasks like string matching or trying to see if a particular string is present or not, like all those kind of basic operations, as well as some advanced operations which have been provided by Python on strings. Now, what we'll be doing is we'll be using two-dimensional list, which is most of like you might have heard of a matrix. In mathematical terms, we have a matrix of let's say size 2 by 2. Then how do we write that matrix is like in this fashion originally, like just ignore this thing. So originally, how do we write a matrix of 2 by 2 is like it contains two rows and two columns. So usually it's like 1, 2, and then again like second row would be like 3, 4. So this is a 2 cross 2 matrix where it contains two rows and two columns. Same way we can have 3 by 3 matrix also, like 1, 2, 3, then 4, 5, 6, and then 7, 8, 9. So this is my 3 cross 3 matrix. So similarly, we can have any like n cross n matrix where n is my number of rows in the matrix and m can be number of columns in my matrix. So if you want to do like matrix addition, right? Like we have two matrix, 1, 2, 3, and 4, and we have another matrix called as 2, 2, 3, 3. And if you want to add these two metrics and provide output, so how do we do that using Python? So look at this structure of the matrix. We can straightforward see like it's not single dimensional, but it's like a two dimensional because it contains elements in horizontally as well as vertical direction. So this is like a 2 cross 2 dimension of numbers. Now in order to solve this, how we'll be doing is we will utilize list in Python, but within my list, I will structure it in such a way that my matrix will show in that list in a two-dimensional format. Now, example here is, let's say my first matrix was 1, 2, 3, 4, as we shown here. Now, how do I create that same matrix in Python? So I can give a variable name as it is, like my list name, which can be like matrix 1 equal to, and then I can have my elements 1, 2, 3, and 4. Now, this is a regular mathematical notation, but in Python, we can embed these initial rows, like all the rows, into a single list. So my first row can be embedded into my first list and second row into my second list. And how do we separate? Separate using comma. Now this two lists are helping us understand that this is a matrix, but how do we embed these two lists? We can embed these two lists into a single list by providing a open bracket and a close bracket. So this way we are creating a list of metrics. And this is the correct structure for storing any metrics into a Python. So this is my list where my parent list is this, the opening and closing bracket. And inside my parent list, I have is two list, which is my first list is this and second list is this, where I'm separating these two lists by a comma and each of the list is containing one row. Now, if I put it in a single way, this is the way where I can store a single matrix in a Pythonic way, where I am having is a parent list and inside this list, I have is another child list separated by commas. So if I run it I am getting an error. Okay, my list invalid syntax error. Okay, so it was because we are not putting a comma inside here. Yeah. So as usual, like any elements which are present inside a list should also be comma separated. So that's the reason we were getting this error. So if we move it back, if I run it, I'm not getting any message. So this is a way of storing a 2x2 matrix in a Python. Now, just to understand for a visualization, the way I did was I took every list on a single row so that we can see this is my first matrix. Now, similarly, how can I write my second matrix is the same way. Matrix 2 equal to, and my first matrix was 1, 2, 3, 4. Then I can have like 2, 2, comma, 3, comma, 3. So this is my second matrix. Now, just for our understanding, we can structure it in this way so that we can visualize like this is my first matrix and this is my second matrix. Now, what do we need to do here is we need to write a program to add these two matrices. Now, how do we add? Usually in mathematical terms, like if you have these two matrices, 1, 2, 3, 4. 1 second. Okay. So we have this matrix 1, 2, then 3 and 4. And then second matrix is 2, 2, 3, 3. Now, how do we perform addition of these two matrices is we take the first element of my first matrix, which is 1, and then the corresponding element of my second matrix, which is 2. So we add these two corresponding elements, 1 plus 2. So my output comes out to be 3. Similarly, I add this second element of my first matrix, which is 2, and then second element of my second matrix, which is 2 plus 2 becomes 4. Same way, for bottom rows is also going to be same. It is 6 and 4 plus 3 is 7. So these four numbers 3 comma 4 and 6 comma 7 should be our output. So that should be the expected output if I'm trying to do matrix addition using Python or like any mathematical way. Now, how do we do this in Python is something interesting. So in order to store the final values of these two matrices, like when we add in the values which we got 3, 3 and 6, 7, if you want to store that, we'll do is we'll take a corresponding result matrix like this, and we will have by default values as 0 for both positions. So this creates a third matrix, which is this result matrix, and by default, we are saying its initial value should be 0 because we haven't performed any addition. So by default, initially it should be 0, and post addition, this result should have all the final values. So this creates a first initial structure of our code. Now, how do we add these matrices? Now to add this matrices, first thing we'll again jump back is let me do a little bit zoom out. Yeah. Now, first thing, as we are doing for any other program, we'll create a function for this. Function can be matrix add, and input here would be three matrices now because we have is this first input matrix, second input matrix, and the result. So result would be added there. So we can have is matrix 1, comma, matrix 2, comma, result, and then put a colon. Here comes is our matrix addition logic. Then we have is this declaration, and post declaration, I will call this function. And this function, I will pass this parameters which we have. So matrix 1, 2, and result. So this creates the structure. Now the main part over here is how do we add these two matrices. Now in order to add any two matrices, it's basically very straightforward as we need to use this two for loops. The first for loop is going to go through every row, and the second for loop is going through every column. So 1, 3 and 2, 4, 2, 3 and 2, 3. So using those two combination of two for loops, we'll go through each and every element of those matrices. So we'll go through this element first, then second element, then third, and then fourth. So that we are going through each and every position, and at that position, we are grabbing these two elements and adding and storing it. So let me show you how to write those for loops. So we'll have the first for loop called as for I in range, and the range here would be length of matrix 1. Same way, I have my second for loop for j in range, and the internal loop is going to be length of matrix 2, or it can be matrix 1 also because the sizes of both of the matrix are same. So let's take length of matrix 1, but we will have the length of the column. That's why we are giving is 0 over here. So this initial for loop is going to give me length of rows in matrix, and this one is going to give me length of columns in matrix. Now if you're not clear, what we can do is we can just print this I comma j and see how it is showing up. Print ij, and if I run this, I should see all the positions within this 2 cross 2 matrix, which will obviously shown you. So 0 comma 0 is the first position of a given matrix, which is this is 0 comma 0 position. Then this is 0 comma 1. Then this position is 1 comma 0, and this one is 1 comma 1. So using these two for loops, we can get the corresponding location like 0 comma 0. The first one is basically telling like it's accessing this location 0 comma 0. And now since we have these location, we can use this location pointer for any of the matrices like matrix 1, 2, or the result. So it can work for all the three. So since we have the location, now we'll be doing is result of I comma j, which is this location, equal to matrix of I comma j, which is accessing this location, and matrix 2 of I comma j. So basically it's the straightforward like result of I comma j, which is this location, equal to matrix of I comma j plus matrix 2 of I comma j. So that way we are adding 1 plus 2, which is 3, and that 3 is being stored here. And how this all things are happening is because of these locations which we are getting using this loop. So quickly to show you here, now how we can do is result of I. Now in Python, we cannot write I comma j here because it won't work because it's basically acting like a list. So in order to access that list, we'll just give us two-dimensional array. So my first dimension and then second dimension. So I comma 0 is result of 0 and 0 means I'm accessing this location. And why is that 0 comma 0 is because of this I and j values, which are these. So result of ij equal to matrix 1 of I and j plus matrix 2 of I and j. If I just remove this block, and once this two for loops are executed, that means it is going through each location, like it is accessing this location, doing the addition, storing the result. Later on, it is going to this location, performing the addition, storing the result, and same way for the other two locations. So by completion of these two for loops, finally all the result is going to be stored in this result array. And once I print this result matrix, we should see the output of two matrix additions. Now if I run this, I'm seeing 3, 4, 6, 7. So 3, how it is coming is 1 plus 2, which is 3. Then the 4. So 2 plus 2 is 4. Same way, 3 plus 3 is 6, and 4 plus 3 is 7. So this way, we are creating a result matrix initially, which was declared for 0, 0 to this final one. So this way, we can perform this matrix addition. Now, the only key part here was to how do we define the matrices in two-dimensional way, which we got to know now. Like it's nothing but like having list inside my list. This way we can create two-dimensional arrays. And how do we loop through these two arrays? And the looping was nothing but like using two for loops, where my first for loop was going to range length of matrix. Now, why this length of matrix was? If you just print this length of matrix, right now this is my program, and if I just print here length of matrix is nothing but number of elements which are present in my matrix 1. So how many number of elements are present in my matrix 1? There are two elements. Now here this matrix 1 contains two elements. This is the first element and this is the second element. So this is what, like every element in this my matrix 1 is a list. So if I print, you'll see there are like two elements present in my list. So this 2 is getting printed from here, and that is how we got length of my matrix 1 is 2. So this is first element and this is second element. Same way, I want to go for a loop on my columns. Now the reason I took this length of matrix 0 is if I just do length of matrix 1 of 0, matrix 0, and if I print this, you'll see it is 2. Now what is my matrix 1 here? My matrix 1 is this, okay? And what is my what is my matrix of 0? Matrix of 0 is if I print, it is nothing but the first element of my matrix 1. So if I print this, it is going to show me 1 comma 2 because this is my matrix 1 of 0th element and its corresponding length is 2. And if I put a length here, it is giving me the corresponding length of matrix 1, which is 2. And that's why we are getting answer here is 2 comma 2. So if I'm saying 2 here, how it is going is from 0 to 2, and then here also from 0 to 2. That's why we were getting 0 to 1 answers based on the positions, because range, if it has from 0 to 2, range will go from 0 comma 1 only, from 0 to 1 and not 2. Same way for my second column, it is also going to go from 0 comma 1 and not 2, because the range is going to go until end minus 1, which is 0 to 1. So this way, using this for loop and range and cascading of list, we can perform basic operation of adding two matrices. So I hope now this should be clear. Is there any question?
So what if we need to print the output in the matrix form?
So if we need to print the matrix like in this matrix form, so what we'll have to do is we will have to basically use a for loop to be run over this result. So let's do that. So what we can do is for I in range length of, basically we'll have to use this for loop only, and instead of matrix 1 we'll plug is result. If I print this, if I say print result of I and j plus, and I'll put some spaces here. So this space is just to, or like let's say I'll just run this now so that you'll understand like why I need spaces. So this way I'm getting the internal numbers. Now if I need to format it more way, 3 and 4 on a single line, first thing I need to do is I need to put a break condition, right? Because I need to print only for 2. So if my j, or if my I, let's say if j equal to 1, then if j is not equal to 1, print result of ij, and then put some space here. Let's run. We'll see j is not equal to 1. What is the error here? Okay, it's because the plus. So 3 comma 6. Now 3 comma 6 are still on the another line, right? Result of I. Okay, j is not equal to 1. 3 and 6, was it correct? 3 and 4 should be there, so it needs to be I, so that we are just going through the first row, 3 4. Okay, print result of, since I is not equal to 1, present, and a backslash t. So basically what we need to do is utilize all the internal functions. So backslash t, if I is not equal to 1, so it is going to print, but again it is going to the next line, but we don't want it next line. Okay, so let's do one thing. Print I j 0, then 0. Okay, so I is my 0, and if I is equal to 0, then it should print on the same line. But when I'm printing this, result of I and j is printed here, then next time when again I is 0, it should be printed on the same line. Else it is on the next line. So what is the function here to break or the line break thing? So line break thing is backslash t, and here it should be backslash t. Okay. I think this will also take some time. Why it is taking that time? Okay. Hmm. So okay, okay. So I think so we don't even need to complicate this much. I think there's much more straight way we can do is directly we can print the row within my result. Let's try that. So for row in result, if I just do print row, it should print the corresponding row. Yeah. So yeah, like basically we don't even need to go into that complexity. What we need to do is the final result which we had, we can utilize that result, and then we'll have to use a for every row in my result. I will print the row. So that is how the printing of row happens. Now, if we don't even need this brackets and the commas, what we need to do is row of 0, comma, row of 1. That way, we are removing all the brackets also. So this is basically easy. Yeah, we don't need to go into the previous logic which I was using. It's just this straightforward loop for printing metrics in structured format. So this way we can print it. Is there any other thing which is in mind like to be done?
No, sir.
Okay, so let me save this program. I think so this session has just like 5 minutes left. What we can do is we can reconnect on the link, like with the new link, and then we'll move forward with the next programs. Let me see if ma'am is available.